this video, we're going to take a look at tangent lines and normal lines. Let's start with a quick sketch. So let's say we've got a generic curve here. Just choose a point on that curve, and let's draw the tangent line to that point. So maybe our tangent line looks something like that. The normal line is the line that is perpendicular to the tangent line. So maybe our normal line looks something like that. So the key thing to remember is that the two lines are always perpendicular. Of the normal line, let's write that as m normal. M just being a generic way of describing slope, so m normal represents slope of the normal line. Slope of the normal line is the negative reciprocal of the slope of the tangent line. Remember, anytime we have perpendicular lines, their two slopes are going to be negative reciprocals. So this is one way of describing that. You can also think of it as saying slope of the normal line times slope of the tangent line is equal to -1. So just a different way of expressing that idea. Two perpendicular lines always have slopes that multiply to -1. So with that idea, let's try an example. Let's say we've got a function that looks like y equals 3x plus 4x squared, all cubed. And the problem is to find the equation of both the tangent and the normal lines. And let's do that at the point 1, 343, which lies on this curve. So let's start with the tangent line. We'll just do tangent line first, and then we can worry about the normal line. So first thing we should do here is figure out the slope of the tangent line, and remember that that comes from the derivative. So let's find y prime, or in other words, the derivative of y with respect to x. Well, we've got a chain rule going on here. Our outside function is the function that raises this quantity to the third power. So let's deal with that cube first. The 3 is going to come down in front. Inside function is going to stay the same. And the power is now going to become 2. So we can recopy that inside function there. And then according to the chain rule, we need to now multiply by the derivative of this inside function. So derivative of the inside function would be 3 plus 8x. Okay, so this entire quantity here comes from the chain rule. So what we would like is the slope of the tangent line. So that's the same thing as saying y prime. But we'd like to figure that out at the point given in the question. So we were given the point 1, 343. Remember that this gives us the x and y values of the point in that order. So we actually need to figure out slope of the tangent line at the point where x is equal to 1. So let's write evaluated at x equals 1. And let's plug that into our expression up here. So we can do a little bit of intermediate work here. We'd have 3 times 7 from that bracket there, 7 squared, times 11. Okay, so I've already calculated some of these values in advance. You can pull out your calculator and just confirm that you can get these values as well. So I got 1617. All right, so let's just call that m for now. We've already organized our work, so we know we're talking about the tangent line. The tangent line has slope, 1617, and we've also got the value of the point where we want to calculate the line. So let's call the actual coordinates of the point x1 and y1. x1, y1 is 1, 343. So now at this point, we just need to remember what the equation is for a line that has slope equal to m, and for which we know a point x1, y1. So the formula we want to remember here is that y minus y1 is equal to m times x minus x1. So there might be other formulas for a line that stick in your mind, but this particular formula is the one that you want to use when you know the slope and when you're given a point on the line. So let's try plugging these two values here into this equation, and we can start to figure out the equation of our tangent line. So now plugging into the equation for a line, we'd have y minus 343 is equal to 1617 times x minus 1. So that's just y minus y1 is equal to m times x minus x1. Okay, and now there are two different forms which we can give our answer in. So I'll show you both of those two forms. If we expand this a little bit, we get y minus 343 is equal to 617x minus 617, and then we could solve for y. So y is equal to 617x minus 1274. Okay, so I calculated this value in advance. You may want to just pause the video, try this on your calculator, and make sure you can get a value that agrees with this one. Okay, so this is one good form to leave our answer in. We have written our answer as y equals mx plus b, which is known as slope-intercept form. Okay, so some questions will specifically ask you to give your answer in a specific form, so you should be familiar with this terminology here, slope-intercept form, y equals mx plus b. The other way we could give our answer is just by moving everything over to one side of the equation. So we could move everything over to the right here. 1617x minus y minus 1274 would be equal to 0. So we could write equals 0. You could have the 0 over on the left side, doesn't really matter. Just looks a little bit more natural to have it over like this. So we've moved all our values over to one side of the equation. That's called standard form. Okay, so standard form looks like ax plus by plus c equals 0, where a, b, and c are integers. So there should not be any fractions in standard form. And in this particular question, it wasn't an issue. We didn't run into fractions. But when we now start the normal line in a second, we'll see that, yeah, fractions actually can become an issue, and we'll have to think about how to clear those fractions. So let's move on to the normal line. Well, we already said that the slope of the tangent line at the specific point that we were interested in was 1617. Now, to get the slope of the normal line, we just have to remember that it's going to be the negative reciprocal of the slope of the tangent line. So slope of the normal at the point that we're interested in is minus 1 over 1617. And the point, so let's actually just summarize that as m before we write anything else down. So m is minus 1 over 1617, and the point that we're interested in, still the same point as we used before, 1, 343. So let's plug that into our equation. Y minus y1 is equal to m times x minus x1. Let's plug that in and try to get this into slope-intercept form. So we got y minus 343 is equal to our slope times x minus 1. Let's do a little bit of expanding here. So on the right side we get minus x over 1617 plus 1 over 1617. Now, in order to save us a step here, let's move the 343 over to the right side. It's now going to be a plus 343. So just move that term over to the right side, and we're going to want a common denominator here so that we can combine these two terms. So let's multiply by 1617 over 1617 to figure out what this constant here looks like. Okay, so again, you can pause the video here, try this value on your calculator, and just make sure you can get a value that agrees with the one that I've already calculated here. So y should be equal to, you could write it as minus 1 over 1617 times x, if you wanted to write the slope really clearly here. And as for our constant, well, it's going to be divided by 1617. According to the calculator, the numerator comes out to, pretty big number, 554632. Okay, so there is our slope-intercept form. Okay, to finish up with our normal line, let's try giving it in standard form just so that we've got a little bit of practice with that. For standard form, remember that we need to clear the fractions. There should be no fractions when we're writing it in standard form. So let's take a look at what we've already got here. Notice that the denominator here would be 16, well, the denominator here is 1617. So if we multiplied both sides of this equation by 1617, we would clear all the fractions. So let's go ahead and do that. 1617y is equal to negative x plus 554632. And we're natural here to move it over to the left. And we'd have x plus 1617y minus 554632 is equal to 0. So there is our standard form. So again, just be familiar with the terminology here. If a question asks for slope-intercept form or for standard form, we should be aware of what that means. Slope-intercept form, generally best when you're trying to graph this line here. So graphing the normal line would be easier in this form. Standard form just allows us to have nicer numbers to work with if we were going on and doing a further calculation, because the standard form doesn't contain any fractions.